Hello everyone, this is your junior high school math teacher, and in this video I'll be discussing week number 6, lesson number 2, which is about solving an oblique triangle under case number 1. Of course, this is the learning competency code, and after you watch this video you should be able to state the law of sines, solve the oblique triangles under case number 1 using this formula, law of sines. Now, in this module, you would be able to investigate, analyze, and solve problems involving oblique triangles. The understanding of the different cases in oblique triangles is necessary to be able to systematically solve the problems. Now, before we discuss solving oblique triangles, let us first go back to the previous topic, particularly how did we illustrate the oblique triangle and how do we differentiate this from other triangles such as right triangle. So when we say oblique triangle, it is defined as a triangle that has no right angle. Now this triangle can be classified as what? Acute triangle, where all its angles are acute. Angle measures are less than 90 degrees, okay, when we say acute angles. Or this oblique triangle can be classified as an obtuse triangle, meaning a triangle with one of its interior angles is obtuse and the other two are acute. So when we say obtuse angle, we are referring to the angle whose measure is more than 90 degrees. Okay? Now, in order to solve the triangle or oblique triangle, we need to know the three parts or the three given parts of which at least one is a side. And there are actually 4 combinations of 3 given parts in an oblique triangle. And these 4 combinations are classified as 4 distinct cases. And at this point, among these 4 cases, we will focus our attention on the first one. Okay? Again, there are 4 possible cases of 3 given parts in an oblique triangle in order for us to solve such triangle. And these are the following, or should I say, let us take one of the 4 combinations of 3 given parts or 4 cases. So under case number 1, the 3 given parts in an oblique triangle are one side and 2 angles. Okay? So if we have an oblique triangle like this, obviously we call this, we name this oblique triangle as triangle ABC. And the vertices are A, B, and C. Therefore, we have angles A, B, and C. And we have the 3 sides, segment AB, segment BC, and segment AC. Now, what are the 3 given parts in this triangle under case number 1? We have this one, segment BC, whose length is side small letter A, together with 2 other given parts that are actually both interior angles. So if this is side small letter A, the measure of angle A is denoted by alpha, and another angular measure on angle B, which is denoted by beta. Now these are the 3 given parts. Therefore, to solve this triangle, it means we need to know the measures of the remaining 3 unknown parts. And what are those 3 unknown parts? The measure of angle C, this segment right here, and this segment right here. Now, these are the three unknown parts that we must know their measures. So that is what we mean by solving this oblique triangle under case number 1. Okay? Next. Okay. That should do it for now. We will have case number 2 in our next topic. Okay? So, now, how do we solve an oblique triangle whose three given parts under case number 1? Obviously, we need to make use of a certain equation for us to find the measures of the other three parts. Okay? And what is that equation or formula? Now, in solving the oblique triangles, we make use of the so-called law of sines or sine law. Now, what is this sine law? Okay. So, for us to discuss this concept, again, we consider an oblique triangle such as this one. And let us name this as triangle ABC. And these are the given parts. Point A with the angle A, of course, and its opposite side denoted by small letter A. Point B or angle B and its opposite side denoted by small letter B. And point C, which is also angle C, and its opposite side small letter C, denoted by small letter C. Now, this is an oblique triangle. Obviously, we have three sides and three interior angles. Now, if we're going to solve this triangle, we make use of a formula or an equation, and that formula is known as the law of sines. Now, what is this law of sines? So, if we're going to state the concept or the statement behind the law of sines, ito yun, no? In a triangle, now, law of sines states that in a triangle, the ratio of the length of any side to the sine of the opposite angle is constant. So this is the statement under the law of sines. Now, if we're going to consider the mathematical statement of this one, in symbol, we have this formula or mathematical statement. That is side small letter A over sine of angle A is equal to side small letter B over sine of angle B, which is also equal to side small letter C, which is equal to sine of angle C. Or we can have this formula wherein the position of the numerators and denominators are interchanged. Therefore, we can consider also this mathematical statement as the law of sines, which is sine of angle A over side small letter A equals sine of angle B over side small letter B, which is also equal to sine of angle C over side small letter C. Okay? So, any of these two equations refers to the law of sines. Okay? It means isa lang silang dalawa. Okay. With this principle, let us now try to use this in some illustrative examples. Let's take number 1. Okay. So, in triangle ABC, side small letter A is given as 16, and its opposite angle A measures 40 degrees together with angle B, whose measure is 58 degrees. So, it means we're going to solve this oblique triangle. So, we are going to find the measures of the three remaining parts. And what are those three remaining unknown parts? We have side small letter B, side small letter C, and angle C. Now, we need to take note that side small letter A is the length of segment BC, side small letter B is the length of segment AC, and side small letter C is the length of segment AB. Now, if we're going to draw the triangle, such as this one, we're going to label those three known parts or the given parts in this triangle. So here, we have angle A. So it measures how many degrees? 40, and its opposite side, small letter A, has a length of 16, together with angle B, whose measure is 58 degrees. Now, these are the three given parts. So obviously, the other three parts are the unknown. And those parts, we need to find their measure. So basically, we're going to solve this right triangle, oblique triangle rather. Okay? So this side right here, it has an unknown length. So we need to find out the length of side small letter B together with the length of side small letter C and its opposite angle C. We don't know its measure at this point, so that is also a question mark. Now, among those three unknown parts, we need to choose which must be solved first. And I think among the three unknown parts, it is the easiest part that we can find its measure is angle C by applying what? The angle sum theorem of any triangle. Okay, so solution. Of course, this is the formula, the law of sines. Okay, now, so we need to set aside the third ratio. Why? Because the two ratios are those we need to use, because this is where we substitute the given information here, no? So, side small letter A is given as what? 16. Angle A right here is given as 40, and angle B is given as 58. And we're going to solve for side small letter B. So, that's the reason why we need to retain these two ratios and we take away this one for a while. Okay? So at this point, we are looking for the length of side small letter B. So this is the ratio, and then we plug in the given values or the given parts. So from here, the proportion would become what? A 16, then A here replaced by 40, and B here, or angle B, is replaced by 58. And transforming this equation, solving for B, we have this equation. So you cross product these two, so it becomes 16 sine of 58 degrees divided by 40, which is your B. And applying the symmetric property, we interchange the position of the left and the right side. So the equation can also be written as what? B from the right becomes to the left equals this one from the left are now on the right side. Okay? And then using your scientific calculator, we replace sine 58 and sine 40 by their respective equivalent values using the scientific calculator. So B therefore is equal to 16 times sine of 58 degrees, which is 0.8480, over sine of 40 degrees, which is 0.6428. Again, using your scientific calculator, we can compute for the length of side small letter B, and that will give us what? 21.1. Therefore, this side right here has a length of 21.1. Okay? Next. The next unknown parts we need to solve here is the measure of angle C. So basically, we just apply the angle sum theorem. Okay? We know that in any triangle, the sum of the measures of the three interior angles is always what? 180. So, setting up this equation for angle C, we have angle C is equal to 180 minus the sum of these two known angles. So, that is 40 plus 58. So, that the resulting equation would be what? 108 for angle C. That is, angle C is equal to 180 minus the sum of 40 and 58 degrees. And that will give you for angle C as 82 degrees. Therefore, the opening here has a measure of what? 82 degrees. Okay? And finally, the remaining unknown part is the length of segment AB, denoted by small letter C. So at this point, we refer to the formula, and this time we make use of this one. Then, for the other two ratios, isa dyan ang aalisin muna natin. And that is what? Okay. So, we take away the middle ratio and retain these two. Okay. So, again, 16 and this is 40, which is equal to C, and we replace the equivalent of angle C, the one we just solved, which is 82, no? Yeah. From this formula, so what you call this? Transforming the equation solving for C, so we cross multiply. The equation would become C is equal to A times sine of angle C over sine of angle A. So from that equation, we substitute the given, the known parts. So A is 16, then sine of angle C, this one, which is 82 over sine of A, or sine of 40 degrees. Now, using your scientific calculator, we replace sine 82 degrees and sine 40 degrees by their equivalent values. 0.9902 for this one, and 0.6428 for this one, sine of 40 degrees. Now, using your scientific calculator, we can compute for the length of side small letter C, and that will give us what? 24.65 units. So here, the value here is 24.65 units. And at this point, we just solve this oblique triangle under case number 1. Okay? Now, let us proceed immediately to the next example. This time, we are going to solve a problem, which is again related to solving an oblique triangle under case number 1. Now let us read the problem. An airship passed directly over two tracking stations A and B, which is 145 yards apart. Now when the airship is between the two stations, the angles of elevations at point station A and station B are measured 70 degrees and 62 degrees respectively. So it means the angle here, the 70-degree angles are at point A and 62-degree angles are at point B. So ito yung respective vertices nila. Now, how far is the airship from station A, and how far this airship this time from station B? Now, for us to analyze this problem, let us consider an illustration for this problem. And this is the illustration. Okay, so this is the airship. And according to the problem, this flying object passes through two stations, station A and station B. Now, at this moment, the airship is between the two stations. So at this point, say point C. And of course, the two stations are 145 yards apart. Now, at this point, from the observer at station A, he or she sighted the airship with an angle of elevation of 70 degrees. Then similarly, an observer from station B sighted the same airship with an angle of elevation of 62 degrees. So, the problem is asking for what? The distance of the airship from station A and the same airship, its distance this time also from station B. So basically, we're going to find the length of this side, okay? And also this side. And you will notice that the problem, in analyzing the problem, we just formed an oblique triangle here. One of the three sides are known, which is 145 yards. And according to the problem, this is the distance between the two stations. Now, the two unknown sides are those, according to the problem, are the distance of the two stations from the same airship. Okay? So basically, we're going to solve this oblique triangle, finding the measures of the two sides. Okay? Although the problem is not asking for the angle formed by these two sides. Okay, now, what do we do? So for our solution, let AC, this one, be the distance of the airship from station A, and BC, this one, be the distance of the airship from station B. And we make use of the formula of the law of sines. Of course, AB, segment AB has a length of 145 yards, which is actually the one that denotes, that indicates the distance between these two stations, A and B. Okay, why do we have this equation? So at this point, we are trying to find the measure of angle C here, okay? And by doing so, we just apply the angle sum theorem. We know that in any triangle, the sum of the measures of all the interior angles is always 180 degrees. So let us plug in the two given angles to this formula. So that this equation becomes what? 70 plus 62 plus C, angle C, is equal to 180. Now, solving this resulting equation for angle C, therefore, your angle C is 48 degrees. Okay? Ayan. So, it means the opening from this angle is 48 degrees. And at that point, for the distance of the airship from station A, I think we need to use the formula for the law of sine. So that is what? AC over sine of angle B is equal to AB over sine of angle C. Ayan. Substitute, okay? B is replaced by 62. Then AB is replaced by 145 and C is replaced by 48. Okay. Then solving for AC from this equation, so we do the cross product. It means we need to multiply 145 by sine of 62 degrees. Okay, so the product would be what? 145 sine of 62 degrees over sine of 48. So therefore, using the scientific calculator, we can determine the equivalent values of sine 62 and sine 48. And those are what? 0.8829 and 0.7431 respectively. Meaning, this value here is for sine 62 degrees and 0.7431 is the value of sine 48 degrees. Then, by computation, AC is approximately 172.29 yards. So, ito yun, no? Yan. So, this is the distance of the airship from station A, which is your AC. Okay? Next, ayan. For the distance of the airship from station B, we have this formula, law of sines. So, BC over sine of A equals AB over sine of angle C. Ayan. So, substitute. So, A for 70 degrees or 70 degrees for angle A, 48 degrees for angle C, and AB here is 145. Now, transforming the equation, solving for the length of segment BC, we have this one. BC is equal to 145 multiplied by sine 70 degrees over sine of 48 degrees. And using your scientific calculator, we can determine the equivalent of these two. Okay? So that the resulting equation would be what? 145 times 0.9397, which is your sine of 70 degrees, over 0.7431, which is the equivalent of sine of 48 degrees. Now, using your scientific calculator, we can compute for the length of segment BC, and that is what? 183.35 yards. So, therefore, the distance of the airship from station B is 183.35 yards. So this is 183.35 yards. Okay? Ayun. Okay? Looking back at the figure, So the distance of the airship from station A is 172.29 yards, while the distance of the same airship from station B is what? 183.35 yards. Okay? Next, for our next problem, how about this one? A pole is slanting 12 degrees away from the vertical. To hold the pole up, a guy wire is connected to the top of the pole A and anchored in the ground B. If the pole is 96 feet, how long the guy wire makes an angle of 45 degrees with the ground? What is the angle formed by the pole with the ground at point C? Now, how long is the guy wire? Okay, so medyo mahaba. Now, this is how we analyze the problem, no? Okay. So this is the oblique triangle. Now, from this simple drawing of an oblique triangle, which is obviously an obtuse, now let AB, this one, be the length of the guy wire. So this is the guy wire. And AC here is the pole that is tilted at an angle of 12 degrees with the vertical. Okay? So yun. Ayun. And, of course, the pole has a length of 96 feet. And the guy wire, this one, makes an angle of 45 degrees with the ground. Okay, so this is the horizontal ground. Although from the drawing, the line which is actually not horizontal. So, but let us assume that this is drawn horizontally. Okay, so this is the guy wire, and this is the horizontal ground. So let us assume that this is drawn horizontally. Now, so the problem is asking for what? The length of the guy wire. So this is the unknown. The unknown parts from this drawn oblique triangle. So at point C, 90, we know that before this pole tilted 12 degrees with the vertical, it is originally standing vertically. Okay? But since the pole is slanted 12 degrees away from the vertical, we need to find the measure of this angle. So originally, with respect to the horizontal ground, it is 90 degrees. But since it is still again tilted by 12 degrees, so we add 90 by 12 degrees. So therefore, the measure of angle C here is actually what? 102. Okay, so this is 102. Now you will notice that at this point we have already declared the three given parts. Now, among those three unknown parts, the problem is only asking for this length, which happens to be a guy wire. Okay, the length of the guy wire, which is denoted by segment AB. Okay, now, so basically we use the law of sine here, no? Yan. To find the length of the guy wire, we set up this proportion based on the law of sines. That is AB, the one we're going to look for, over the sine of its opposite angle, C, whose measure is 102. Then equate that to the ratio of another side that is known, which is 96 degrees, over the opposite angle, which is also known measure, which is 45 degrees. So, substituting the given values to this proportion, so we have AB is equal to sine of 102 degrees. AB over the sine of 102 degrees equals 96 over sine of 45 degrees. Now, using the scientific calculator, AB is equal to 96 times sine of 102 over sine of 45 degrees. And from this equation, we replace sine 102 and sine 45 degrees by their respective equivalent values. Now, for sine 102 degrees, that is 0.9781. And for sine 45 degrees, that is 0.7071. Again, using your scientific calculator to finally get the length of the guide wire, so that is AB, we have AB is equal to 132.79 feet. Therefore, this one right here, which is the length of the guide wire, has a length, which is the guide wire, has a length of 132.79 feet. And this is the answer to our problem. Okay? Now, for our fourth example, to find the distance across a river, a surveyor chooses points A and C, which is 160 meters apart on one side of the river. Now, the surveyor or she then uses a reference point B on the opposite side of the river and finds that angle A is 41 degrees while angle C is 55 degrees. Now, what is the distance from point B to A, and what is also the distance from point B to C? Now, to analyze the problem, okay, so let's just say this is the river, the current of water, and these are the opposite sides of the river. Now, on one side of the river, the surveyor chooses 2 points, and these are points A and C. And the distance between these two chosen points is 160 meters apart. Okay? Then, he chooses another point, which is the reference point, and he or she named this as point B. So, dito siya nag-observe, no? Now, using a device, the surveyor finds out that at point A, the angle formed by his line of sight with this segment is 41 degrees. And then at point C, she found out that the angle from this point is 55 degrees. So the question is, how far is this point from point A, and how far is this point B from point C? So basically, para lang itong problem na to ay parang kagaya lang nung diniscuss ko kanina lang about the airship that passes between the two stations A and B, no? Ayan. Kung ikukumpara natin ito dun sa airship, parang ito yung airship, ito yung station A, ito yung station B. Okay? Parang ganun, no? Ayan. So the two broken line sides are the one we're going to look for, no? Now, these are the three given parts. So basically, the three given parts under case number 1, okay? Given one side and two angles, okay? So, basically, we use the law of sines here, okay? So, for our solution, let AB be the distance from B to A, this one. And also, similarly, we let BC be the distance from B to C. At point B, of course, we need to find the angle formed at point B. So, we use the angle sum theorem. Therefore, to get the measure of angle B, we simply subtract the sum of angles A and C from 180 degrees in order to find the measure of angle B. So, in this case, B is equal to 84. Okay? Yan. Now, to find the distance from B to A, we solve for the length of segment AB using the law of sines. And this is the formula. Okay? AB is over sine of 55 degrees is equal to 160 over sine of angle B, which is 84 degrees. Now, transforming the equation, solving for B, meaning 160 is to be multiplied by the equivalent of sine 55 degrees over the equivalent of sine 84 degrees. And using the scientific calculator, sine 55 degrees is this one, 0.8192, while sine of 84 degrees is equivalent to 0.9945. Then, by computing the length of segment AB, that will give us what? 131.8 meters. So, ito yun. Okay? Now, what about the distance of point B from C? Or point B to C? So, basically, we solve for the length of segment BC from this triangle. So, that is BC over sine 41 degrees is equal to 160 over sine of angle B. Okay? Then solving for BC, so that is 160 times sine 41 degrees over sine 84 degrees. Again, using your scientific calculator, that will give you 160 times 0.6561 over 0.9945. Okay? And the distance from point B to C is actually 105.56 meters. Now, these are the answers. Okay? Yun. And this one. Next. A tree on a hillside casts a shadow of 215 feet down the hill. If the angle of inclination of the hillside is 22 degrees to the horizontal and the angle of elevation of the sun is 52 degrees, find the height of the trees. Okay, so for our solution, let us analyze. Now, this is the hill. A tree is located here and it casts, so if this is the sun, the tree casts a shadow, ito yun, down the hill, whose length is what? 15 feet. And the angle of inclination of the hillside is what? 22 degrees. This one, no? Yan. Ito yun. And the angle of elevation of the sun, this one, with respect to horizontal, the broken horizontal line is what? 52 degrees. So the problem is asking for the height of the tree. Yan. So what do we do with this one? Okay, let us analyze. Yan. Now let us try to redraw the figure by emphasizing that there is an oblique triangle. There is an oblique triangle here. Okay? So now, you will notice that in this angle right here, we need to compute for the angle, which is what? 30 degrees. Now, how did we get 30 degrees? That is actually the difference between 52 degrees and 22 degrees. Yan. Then what else? Okay. Now, if we're going to project our horizontal broken line, you will notice that this broken horizontal line here is parallel to this horizontal broken line also. And we know that from the principle of parallelism, if parallel lines are cut by the transversal, therefore these two angles are congruent and we call them corresponding angles. Okay? So if we're going to project this is 90 degrees, and we know that an angle here is also 22. So 90 plus 22, that is 112 degrees. And you will notice that this triangle here is an obtuse triangle. So we have 30 degrees, this is 112. So it means the remaining angle from here is 38. Okay? Meaning, how did we get 38? We simply subtract the sum of 112 and 30 from 180 degrees. So that is 38 degrees. Okay? Now, again, we finally redraw the figure for the third time so that we can only have an obtuse triangle. So we name this triangle as triangle ABC. Okay? Now, this one right here is the shadow of the tree, and the vertical side is happens to be what? The height of the tree, which is the one we're looking for. Ayan. Which denotes what? Segment BC. So basically, from this triangle, we are actually looking for the length of segment BC here. Now, this is the given side, and its opposite angle is the 38-degree angle C. Ayan. So basically, from this triangle, we can now compute for the length of segment BC using the law of sine. Okay, ayun. Okay, let me present to you uh, the computations that we did for those angles that we must compute. Ayan. Okay. Now for segment BC, that is, okay, BC over angle A is equal to, now for the ratio, we must see to it that the ratio that we're going to equate to this ratio, having the unknown, the one we're going to solve, is the length of one side and its opposite angles are both given. Okay? So alin dito sa triangle na to yung dalawang parts na na opposite to one another na given. Okay, 215. This is the side, and the opposite angle is also given as 38 degrees. So that is segment AB over sine of angle C. Yan. Then substitute. So 215 over sine of angle C, which is 38 degrees, is equal to BC over sine of 30 degrees. So, solving for the length of segment BC, that will give us 215 times sine 30 degrees over sine 38 degrees. Now, using the scientific calculator, we can compute for the equivalent of these two. Okay? So, applying the symmetric property, we can interchange the position of the left and the right side of this equation. So, BC is equal to this one. Yan. And then, so that is 215 times sine of 30, which is 0.5, over sine of 38, which is 0.6157. And at this point, we found out that upon computation, the length of segment BC is 174.61 feet, which happens to be what? The height of the tree. Okay? Yeah. Which is the one we're looking for.